Hello, I'm Mr. Parker and this is question 1 on the OCR Mechanics 1 paper from June 2013. For more questions on this exam paper, click the link here or check in the video description. Question 1. Three particles P, Q and R have masses 0.1 kg, 0.3 kg and 0.6 kg respectively. The particles travel along the same straight line on a smooth horizontal table and have velocities 1.5 meters per second, 1.1 meters per second and 0.8 meters per second respectively. P collides with Q and then Q collides with R. In the second collision, Q and R coalesce and subsequently move with a velocity of 1 meter per second. In part 1, we need to find the speed of Q immediately before the second collision. In questions where you have three particles, you usually want to isolate just two of them and work with two at a time. But you've got to choose carefully which particles you work with. We want to find the velocity of Q before it collides with R, but that means P has already collided with Q. So we actually need to choose Q and R to solve this problem. I'll show you why we need to choose Q and R by trying it with P and Q and showing you where we get a problem if we do that. So as always, we start by drawing a diagram. Before the particles collide, we've got P moving with the velocity of 1.5 meters per second and Q moving with a velocity of 1.1 meters per second. P has a mass of 0.1 kilograms and Q has a mass of 0.3 kilograms. After the collision, they still have the same masses. But after the collision, we have two unknowns because nowhere in the question up here does it tell us the velocity of P or the velocity of Q after the collision. So here we've got a problem because we've got two unknowns, so we can't solve this problem straight away. So let's instead start by working with Q and R. We know that Q has a mass of 0.3 kilograms and R has a mass of 0.6 kilograms. Immediately before they collide, we know that R has a velocity of 0.8 meters per second, but we don't know the initial velocity of Q, so we'll call that UQ. After the collision, we know they coalesce. That means that they move together as one particle, and that particle will have mass 0.9 kilograms, and it tells us the velocity of that particle is 1 meter per second. So here we only have one unknown, which is UQ, the thing that we want to find. So we set up our conservation of momentum equation that says the momentum of the system before the collision is the same as the momentum after. So the momentum of particle Q is its mass, 0.3, multiplied by its velocity, which we've called UQ. If we add to that the momentum of R, so that's its mass, 0.8, times its velocity, 0.6. Remember, these quantities are both positive because they're both travelling in the same direction, and I've chosen right to be the positive direction. So here's the momentum of the system before the collision. After the collision, we've got a combined mass of 0.9 and a velocity of 1. If we tidy this up a bit, we get 0.3 UQ plus 0.48 equals 0.9. We can then subtract 0.48 from both sides and get 0.3 UQ equals 0.42. We'll then divide both sides by 0.3 to get UQ equals 0.42 over 0.3. And if we put that into our calculator, we get 1.4 meters per second. In part 2, we need to calculate the change in momentum of P in the first collision. This time we do want to work with particles P and Q, so let's start by drawing a diagram. Unlike last time, we no longer have two unknowns because we worked out the velocity of Q in the previous part. It was 1.4 meters per second, so we can now add that to our diagram. The only thing that we don't know in this momentum equation that we'll set up is the velocity of P. Once again, we'll set up a momentum equation. We've got the mass of P, which is 0.1, multiplied by the velocity of P, which is 1.5, and we'll add to that the mass of particle Q, which is 0.3, multiplied by its velocity, which is 1.1. This represents the momentum before the collision. After the collision, V still has a mass of 0.1. Its velocity we've defined as Vp, and Q has a mass of 0.3 multiplied by a velocity of 1.4. 0.1 times 1.5 is 0.15. And if we add to that 0.3 times 1.1, that's like 3 times 11, that gives us 0.33. And on the right hand side, we've got 0.1V plus 0.42. Simplifying further gives us 0.48 on the left hand side equals 0.1 Vp plus 0.42. If we subtract 0.42 from both sides, we get 0.06 equals 0.1 Vp. If we then divided through by 0.1, we would end up with Vp equals 0.6 meters per second. Now we're in a position to calculate the change in momentum of P because we know its mass and its velocity before, and we also know its mass and its velocity after. The change in the momentum of P is going to be defined as the momentum after the collision. The change in the momentum of P is the difference in the momentum between before the collision and after the collision. Since the mass stays the same, this is equivalent to the difference in the velocities. So we have 0.1 multiplied by 0.6 minus 1.5. 0.6 minus 1.5, that's negative 0.9. If we multiply that by 0.1, we get negative 0.09 kilogram meters per second.